Hello, thank you so much for attending my talk online at PyCon 2012. I'd like to introduce it to you today, the Pandas playing with Apache Arrow. That's a new project that promises to bring a new vision for polyglot data in Python. It's a pleasure to talk to you, especially on these hard times where the people are isolated, the people are cannot interact with each other in person, so it's quite hard, right? So, and the magic of PyCon around the world, especially PyCon US, especially PyCon Brazil, for example, is the network and the community around, right? So let's do it this year online, and hopefully next year everybody will be together in person in the PyCons around the world. Nice to meet you. My name is Robson. So you can find me on any social network like Twitter, LinkedIn, GitHub at Bsum. Currently, I'm a data engineer at Microsoft, living in Berlin. Originally from Brazil, more than 16 years on the road, and since 2010, I've been organizing conference and meetups around the world, especially in Brazil, sometimes helping in Berlin. And you can reach me out anytime that you want. So let's introduce the problem. The problem is to exchange data between data systems. So it is a common problem that you face in teams, in communities. So when you have different roles playing together in the same amount of data, in the same kind of data, so you can face some kind of problems. The problems to change the data between the teams, the data to problems to store this data, problem to perform an analytical operation on this data for cheap prices. So you have different solutions for different problems, but the solutions can be costly or not perform well. So there are different tricks that Apache Arrow comes to try to solve in some parts of this exchange data. Uh, Imagine that you are working a huge system or a huge company or in a small company, whatever. So you have different kind of data being generated every second, right? So you have different data being stored, different data being processed per second, right? So you have numerous sources, including legacy formats, proprietary formats. That is my case, for example, at Microsoft. So I needed to deal with different kind of proprietary formats that I needed to bring to my data system, data warehouse, pipelines, and then I needed to scrub this data, and I needed to serve this data to my customers inside Microsoft in order to be more convenient, to be more easy to access, and they can deliver back the data they changed, the update. And this become a problem to me. For example, especially nowadays, I work with three different teams at my role. Like a team that performs dashboards, basically they show the results to the people who do conduct analysis and machine learning stuffs, and people who works with the data systems, like software engineers that needed to consume my data or needed to analyze my data for some reason. And sometimes you needed to have like a big I/O, a big transfer of data between these teams in order to permit these teams to analyze this data. This is the big problem. Even use like common files like Park files or CSV, most part of these problems are not addressed. Even you can solve it with this technology. So, in another hand, you have like to wait, or you needed to spend a lot of money, right? So this is the real problem. And the first thing that I needed to say to you that CSV does not scale. So forget this idea if you needed to exchange data between the teams. If it can work for small teams, for simple tasks, probably the public of this talk is more data-centric public. So imagine that you needed to have more easy solutions or solutions that perform better, that use proper tools for perform some kind of tasks with data. in general. So how you solve this problem between the teams? In general, you have two concepts. So you have like people working on ETLs or data modification, data scrubbing, and this kind of problem is well addressed for a vast amount of tools. Like for JVM ecosystem, you have Spark, Elasticsearch, Hadoop ecosystem, Hive, Pig, different kind of tools that perform and are able to ingest, modify, and stores and write a vast amount of data, right? So even Python, you can use PySpark and access directly the Spark API and perform this kind of task. You can use Dask as well. Dask is like a Python tool that can parallelize Pandas Dataframes that can be used for ETL tasks, right? So and you have it on other teams for analysis dashboards that need to create deep analysis, machine learning stuffs and models. They need to integrate with the data sciences, and both can use SQL to go to the data and perform some kind of analysis. But in general, the people push this data to a notebook, to some data format like CSV or Perky files into the computer, start to analyze it, and then they try to deliver their results for the customers or try to bring back this data to some kind of storage. So this is the real problem, but is how you access the data today. Sometimes it's painful because let's imagine that you need to analyze 10 gigabytes of data. Even it's easy to download, it's easy to transfer. Sometimes you have no enough space in your notebook or on your machine, or you don't have like enough infrastructure to perform, like memory, or not a good network to download this data. So you needed to find ways to solve this kind of problem, right? And then the first thing that the community, the companies, the people adopted was Perky Files. Perky Files is an Apache project, right? Perky Files basically are a columnar file format that was designed by the community to archive a vast amount of data. Basically is that. So they fits pretty well with distributed file system like Hadoop. They were projected for that, right? And one of the main features in the Perky files, they were designed to be compressed, or it means they save a lot of space, and for I/O. So it means that they solve the problem of latency, right? So because it is compressed, so the traffic in the network is less than you need. So then you can send data or bring data from your data process, right? So they are encoded format. It means that they are specifically encoded format. And if you needed to read these Perky files from different technologies, you needed to implement this decoder or serializator in order to read or to write, even to write, right? So this does solve the problem at all. Even is well used, right? Another thing about Perky file, even you push like Perky files to your infrastructure, to your machine, they need to be decoded from start to end. It means that you need to decode all the file, bring it to memory or to another kind of format, to another data structure that you can analyze. So it works different in different technologies, like Python and Spark. For example, they have different implementations of data frames. That is a representation of some kind of Perky files, data structures. But the implementation of these data frames are completely different in these both technologies, right? And Parquet doesn't provide memory data structures. It means that when you deserialize, when you decode the data inside of the Parquet files, there's no way to fit into memory. You need to have, as I told, some kind of serializer, right? And depends of the scenario, can be costly. Even it's projected for speed in IO and storage. If you needed to compute Parquet files a lot of times, if you needed to movement the Parquet files, update the files a lot of times, so it might be costly because the way how the Parquet files works is quite different from Arrow. So basically, Parquet files are immutable. So any kind of write operation, basically you need to change or you need to rewrite all the files on the Parquet files. There's another project that aims to solve this problem, like Delta Lake from Databricks company, but it's still costly. Delta Lake, for example, is an open source project that you can implement in your project. You can use Python for that, but it tends to be costly as well. So you need to find another solution for that. And in another side, so Arrow is a library, right? That's provide a columnar data structure to compute the things in memory. This is very interesting because you have, you explain further, but you have like the same picture of your memory, and you can store this picture of your memory in any place, right? Even in a disk if you want. The files in Arrow tends to be bigger than Parquet files, for example, but as I told, Arrow try to solve another problem, right? The first thing about Arrow is the binary protocol that was defined by Arrow community, right? I won't go deeply on this concept, but basically they define how to store in memory or how to map in memory a collection of arrays. That contain values, right? Can be primary types or nested types, right? And this kind of data is used for message or interprocess communication. Like you can put everything in memory, like so. Since you have this picture of the memory in your machine, it can be stored in the disk. So any technology, any language can read it without needed to serialize or deserialize or needed to compound it in memory, right? So you just need to map into the memory, and it can be used for interprocess communication, like any other protocol, right? As I told, so you can store it in elsewhere you want, right? So it's a big advantage. And Arrow includes adapter to read formats like Parquet, ORC, CSV, JSON files, and then you can play with different kind of data formats in order to speed up your process and try to become our data more homogeneous, right? So then you can transfer data between different roles and different teams easily, right? For further information, you can follow this link about the arrow columnar format that's officially called it. But yes, you need to understand this protocol, right? Let's talk about the protocols and the concepts itself, like as defined in the documentation of an arrow, so language agnostic and memory data structure specification. It means that so any language can implement the Apache Arrow specification. One thing that's very interesting and very useful for Arrow, that's Arrow as array. So you can access the elements of this array in a constant time. So and then the elements inside this array is followed by each other. It means that it's a sequential access. the next element and the previous elements are in the same structure. So it's a loop friendly. So you can interact over the data structures in Arrow easily with a less cost. Right, and for the final user is transparent, because even you use like pandas, R, or another data structure for your preferred languages, is this is transparent for the user, because how you are storing, how you are dealing with this data, Apache Arrow is take care of it for you. So you can share the data for all the people that you want, all the team that you want. Let's get, for example, Sparks use Arrow nowadays for common scenario. So you have like a string between Spark SQL and Pandas, for example, and then you need to read this part of data, and this part of data and exchanged between Spark and Pandas is made by Apache Arrow. How? Spark puts the Apache and the narrow data structures in memory, and Pandas can read it, can manipulate it, and maybe can apply Pandas user-defined functions or other things through to this chunk of data, and then bring it back to the storage, right? So you can see this picture from Arrow website, how you organize the data. In the first picture, you have like a columnar format that you have session ID, timestamp, and source IP, for example. In a traditional memory buffer, the rows are grouped by rows, right? The memory is grouped by rows. So you have row one that you have different data. In Arrow, you have an array of values that represents the key, like a key value format. Like for all the section ID, I have all the data. So you can access directly by the section ID, because you know how to access the Apache Arrow know how to access fastly directly in a constant time in the memory. Any technology can reach this performance. Right. Now you need to understand the three main difference between Arrow and Perky files. Perky files even is used to exchange data nowadays, so they are designed to archive data. It means that you need to store it for a long period, and it can be accessed for a long period. It means that you can, for example, have like a big data lake that is being growing for more than 10 years, and if you have Perky files for the 10 years inside your data lake, so you still able to read from Perky files, because they were designed for distributed file system in a scale of Hadoop, for example, right? The second choice is really to read is costly to read the Perky files, right? Because if you needed to update the Perky files, if you needed to read a lot of Perky files, you needed to have like an infrastructure behind the scenes in order to permit you to do it. And in Apache Arrow, you just need your language, so you can just get these files, or you can just access the memory directly, and then you can read Arrow data. So you can basically use your preferred tool. For our case, you are talking about Python and all the Python ecosystem for analytical tool, right? Perky files tends to be smaller than Arrow files on the disk, as I told, so they are compressed and developed by perform good I/O. But 10 arrows in another hand, so you have more speed to analysis. Arrow acts like a central point, so you can consider that Arrow acts as like a central point between the data people in a company. Like you have different people working with the data engineer, data scientist, machine learning engineer. So you have like a business analysis, and they can get all this data using Arrow, and they can interact with Perky files and another technologies. Okay, that said, so it's easy to play with Arrow right now. So considering that you have your environment in your machine, so you just need to pip install Arrow. So right, so I also installed PySpark just to do like a small sample how to interrupt between technologies. I can consider that you have pandas or another technologies in your machine. It's up to you to decide, but right now, this is the first example. So let's simulate some scenario right now. So as a data engineer, I will show some code. Basically, I've downloaded COVID-29 dataset from Brazilian website from Python Brazilian community. Very thanks for make it possible. More transparency. Brazil.io. Right? And as a data engineer, I want to consume this data set, transform this data set, and deliver this data set as a Parquet file in my distributed file system. Basically, it's the sample code does, right? I create a Spark session, I read the CSV, I select the interested columns, I cast the data column to date object from string to date object, and then I write into Parquet files, right? So you have more or less 71K records. And then we can read these Parquet files from our Arrow library and transform it into Pandas Dataframe, and then you can see that you are able to select the data from Parquet files. You are able to perform some selections, some extractions, or whatever you want to do in Pandas, and then you are able to write again to Parquet files. In this case, you get a small part of the data from a specific state in Brazil, and then save it into a specifically Parquet file. It's basically what we did here, right? And then another sample that you can extract metadata from Parquet files if you want using Arrow, right? Also, you are able to manipulate and check the schema from the data, and everything is transparent for Arrow, as you can see here. And here where the magic happens, but it is fully transparent for the users, where you basically write into the file system arrow file. As you can see in my file system, an arrow file is slightly or basically bigger than any Parquet file, even they contains the same values here, right? So you can see the difference, but as I told you, they are designed for different proposals. Another thing that's very important and very interesting, narrow, that they can play well with the ADFS side. So you are in a distributed file system in a company or a community that provides this kind of tool for you. So you can connect it directly to ADFS and play your notebook using Arrow or Parquet. But the focus of your talk is talking about Arrow. It's supported by Python, C, C++, Ruby, R, MATLAB, Go, Rust, C#, JavaScript, and other languages, right? So you can implement your protocol by yourself in our language. It's easy, so the documentation is fully accessible and easy to read. And thank you so much for attending my talk, to watch my talk. So, obrigado. Reach me out on my social network. So, all the stuff from this talk is available on my GitHub. And hope to see you soon, or in person, or in contact with my social network. Thank you so much. Bye bye.